everybody. I am Greg, and it's a pleasure to be able to talk with you all. Thank you so much for the invitation. I'm going to give a little bit of an overview in terms of my personal background, introduction, and talk about some of the stuff that we're working on right now, some of the projects that we're working on right now, what's gone into those projects, a little bit about open source in general. And then I hope to have a nice dialogue and with some good Q&A with everybody here. So please, if you do have any questions, please feel free to write them up. And I believe Rachel's going to be tallying those questions and then asking them at the end of the presentation. So again, thank you. My background originally is in biochemistry. I have a degree in biochemistry, and I kind of made the grand leap into Linux and computers through biochemistry, bioinformatics, and genomics back in the mid-ish to late 90s. I became fairly enamored with Linux and open source at that point, and was really just it was enough for me to completely pivot my career. There's a little bit of background noise on the line just to let everybody know. So I ended up pivoting my career and really focusing it on Linux and in open source. And as I said, I became absolutely enamored with the idea that there is a group of people all over the place, over the internet, working together to come together and create something amazing. And that really shaped pretty much everything that I was to do from that point on. And I got really interested, as I said, in Linux, spent night and days learning Linux and moving from kind of the biosciences and pharmaceuticals into the operating system. Learned everything I can, finally landed some jobs actually doing some Linux in the late 90s, and then landed at the Department of Energy, where I took my background not only in science, but now was able to merge that with the operating system side and do high performance computing. And most of my background at that point moving forward has really been spent at the Department of Energy, building supercomputers, building high performance computing systems and whatnot. So in 2001 was really the beginning of my foray into leading open source projects. I created an open source project called Werewolf. And Werewolf is a operating system provisioning and management subsystem for clusters. It allowed us to really scale the administrative efforts necessary to run big high performance supercomputing systems to the point where it doesn't matter how many nodes a particular cluster has. From the software perspective, it's just one. And all nodes are booting off of the exact same image. We don't install anything. We don't have to configure anything once the node is booted, and they all boot stateless. So Werewolf is the system that allows you to do that. And it's still in use today. We're at Werewolf version 4.3. We're just about getting ready to release. And it's moving super fast now. So it's actually had some ups and downs in terms of amount of contributions from the community. But right now we're actually having a lot of commitment or commits from the community. So things are moving great on the Werewolf side. Now, after I founded Werewolf, I founded another little project that probably a few people are familiar with, a little Linux distribution called Centos. Centos came to be really when Red Hat pulled or end-of-lifed the majority of their freely available operating systems. At the time, it was called Red Hat Linux, and they were trying to get everybody to pivot over to Red Hat Enterprise Linux. The problem for me, as well as many other people, was we were contributors to Linux and various portions of the runtime, and the user space runtime is, and we didn't want to have to basically go pay to use our own commits and our own contributions into Linux. So there was a huge interest in terms of making sure that it stayed freely available. So Centos kind of came to be out of another project that I was working on called Chaos Linux. And Chaos Linux was basically a community RPM distribution of Linux before Fedora existed. But Centos ended up taking off, and Centos took most of the publicity and the uh, the commitment to the project. So CentOS ended up taking off. I separated myself from the project when Red Hat tried to sue me. So at that point, I left the project, and it was run by non-U.S. residents to stay a little bit further away from the legal arm there. And just to share with everybody, they were well within their rights. We were blatantly abusing their trademarks. So in hindsight, yeah, that was probably something we should have paid better attention to and closer attention to. But we did end up fixing that, and but I wanted to also keep it a little bit further away from me personally. So the project moved on. I moved in a different direction, and then I did a few other open source projects. But about, let's say, the next major one I did was probably about 5-6 years ago now. Time's flying. I created a container system called Singularity, and the idea of the container system the idea of the Singularity container system is because in high performance computing, we're using a very legacy kind of traditional HPC architecture, which I'm going to talk a little bit more about this moving forward. But we're using a very traditional architecture that's about 25 to 30 years old at this point. It's the basis of the architecture is called the Beowulf, and it has been a fantastic architecture for allowing high performance computing systems to scale very wide and far. But it is a monolithic style flat architecture, which has made it very difficult for people to integrate with other capabilities coming out of the enterprise, hyperscale, and cloud. And a lot of really great innovation has been happening there, but we have not been able to really leverage that because of this kind of traditional legacy architecture. So Singularity was a container system designed to kind of cross or bridge the gap between what was coming out of the enterprise with regards to containers. Docker at the time was the predominant container runtime. And how do we integrate that into a high performance computing system? And there was a lot of challenges there. But I was able to do that. I prototyped it. I released it to the community. And within about 6, maybe even upwards of 12 months, so not that far from the initial release of the project, almost every big HPC system worldwide was leveraging this this container runtime. So it took off very, very quickly. And the predominant reason was it was solving a lot of kind of critical pain points of what people were asking for. And at the time, people were asking for, scientists were asking for ability to do containers within high performance computing. And so this did solve that in a very painless way for high performance computing systems. So it took off. Then kind of came the idea of what CIQ is based in, which is the next generation of high performance computing. What we learned from the container ecosystem in high performance computing is that there's a lot of capabilities that the enterprise and, as I said, cloud and hyperscale have been developing upon. And a lot of these innovations have been massive. And in HPC, we've been pretty much wearing blinders. We haven't been seeing this because it always seemed like it was kind of different from what we were doing. But containers was really the first step in terms of modernization of high performance computing. And how do we look at high performance computing as an architecture, as something that we can merge and integrate with these innovations coming out of enterprise and hyperscale and in cloud. And so that was really kind of the fundamental tenets of what created this. And we started thinking about how to build high performance computing systems in a way that was cloud native, how to build them in a way that allowed us to go not only multi-prem and multi-system, but multi-cloud. How do we expand the concept of a single system to go federated between many separate systems? And how do we do all of this in a cloud native way? And then lastly, and this is the part I think will be very interesting to the crowd here, is how do you manage the data for the almost the full duration that I've been doing high performance computing, data's been, quote unquote, a problem. Not in the fact that, it's a negative, not at all, but it's something that we didn't really understand how to deal with. And the size and amount of the data that we had got to the point where we couldn't just, always move the data. So how do we know when we need to move the data or when we need to move the job to the data? And this starts bringing up things like data mobility, data locality, data gravity. And then lastly, something we've been thinking a lot about lately, which is just the security model of the data. And how do we start integrating that into the orchestration model for this gigantic federated system? And that's what we've been building. And so I'm going to talk a little bit about that because it's not only super cool. I mean, it's really where we've been spending a lot of effort. But let me first kind of give a high level view of this and how we're approaching this. So apparently I have to focus the right window to go to the next slide. All right, so what we've done is we've created something that's kind of like a cloud native and cloud hybrid, federated computing engine. And it gives us the ability for users to submit jobs, to submit workflows in such a way to the system that the system can orchestrate that not only on a single cluster, but on many clusters and across many clusters. And the major issue that we need to be thinking about here, obviously we have, data access policies and whatnot and user access policies, where are users allowed to run? But assuming that we have kind of a balanced, even system, where are the architectures and the requirements that we need to satisfy a particular job? Meaning, do we need GPUs? Do we need a particular compute architecture? Do we need a particular interconnect? What about a microarchitecture that it's optimized for? How do we make sure that we're landing this job on the right resource, and how do we seek out and find those resources? And then again, kind of coming back to the data, how do we merge this orchestration model with the location and proximity to that data? So that's kind of the high level view of what we started creating with Fuzzball. Now, the next section, or the next kind of piece of this is, well, what if this was the interface that you can use to go between prem and cloud? What if the idea of cloud can actually be brought up a little bit higher, right? What if we can, I've heard a few other people say above the clouds, right? I don't know if I would apply that here, but how do we look at this as a completely cloud holistic way where the cloud becomes not only, well, AWS, Azure, GCP, Naver Cloud, wherever your clouds are. It's not just that, it's also your on-prem resources. And how do we unite all of these into a federated system? So this is what we were working on. This is what we were founded to do. When all of a sudden, Red Hat changed their business model again, and they, over time, they did acquire Centos, and they decided to end of life Centos, and that led us to the next enterprise operating system, which is Rocky Linux. And I'm, by the way, that's me saying it, but I'm repeating what I've heard now other people say is they're looking at this as being the next major enterprise operating system for on-prem, for cloud, for containers, and for virtual machines. And this really came out to be simply because, well, Centos, the operating system that we were leveraging, the operating system that the majority of our customers in high-performance computing was leveraging, which Centos is massively dominated in high-performance computing. Debian, Ubuntu, Red Hat, SUSE, they're much less utilized in high-performance computing than Centos. Centos absolutely has the market share well over 50%. I'd probably say even closer to 70, 75%. And that whole operating system was just end of life with the first end of life date of that being accelerated from December 2029 to December 2021. And so everybody who installed CentOS 8 was expecting another 9 years of production utilization out of that operating system, and those 9 years was cut short. And that became basically the foundation of why we initially created Rocky Linux. Now, a lot of things have changed in the enterprise Linux landscape, and this has to do a lot with kind of what was Red Hat Linux, Red Hat Enterprise Linux, what was CentOS, what was the relationship between them, and to kind of articulate this, Red Hat Enterprise Linux development has previously always happened behind locked doors. And CentOS was basically taking the RPMs, the source RPMs coming out of Enterprise Linux, Red Hat Enterprise Linux, and the goal of that was to try to turn that into a new operating system that was as compatible with Red Hat Enterprise Linux as absolutely possible. So Rocky Linux kind of is a little different from CentOS, but the goals are the same. It's different because of how and what Red Hat did with CentOS. Instead of CentOS being behind Red Hat Enterprise Linux, as it's always been for the last 16 years, all of a sudden, CentOS Stream went in front of Red Hat Enterprise Linux, and they end-of-life CentOS as we know it. So CentOS is gone, but CentOS Stream is alive, and it's in front of Red Hat Enterprise Linux, kind of like a beta, and it sits, it basically has its own GitHub that sits, again, in front of Red Hat Enterprise Linux. And what this means is that now Red Hat development is not happening behind locked doors. And it gives the community the ability to commit into what's going to go directly into Red Hat Enterprise Linux. Excuse me. This is a little different from Fedora because Fedora is way in front of Red Hat Enterprise Linux. This is just a little bit in front. This gives us that ability to commit to what is going directly into Red Hat Enterprise Linux, and for the world to actually be able to provide feedback and context to this. So to be clear, CentOS, as we know it, has been end-of-lifed. CentOS Stream is a kind of a new project. It's a beta version of Red Hat Enterprise Linux, which means it sits in front of Red Hat Enterprise Linux. And we pull from the exact same sources now that Red Hat Enterprise Linux pulls from, and that's Rocky Linux. So Rocky Linux is actually now a sibling of Red Hat Enterprise Linux with the goal of still being, just like CentOS, as compatible as possible with Red Hat Enterprise Linux. But I want to be very clear, the structure has now changed. And if you look at it wholesale over the entire thing, what you see is this is actually a really good series of moves. And it's a good series of moves because what ended up happening was when CentOS was acquired by Red Hat, to be blunt, there was a conflict of interest apparent. Right? CentOS does compete with Red Hat Enterprise Linux. I've heard Red Hat and people say it doesn't. They will never convince me. They compete with each other. Now, that conflict of interest doesn't exist anymore, right? Rocky Linux does compete with Red Hat Enterprise Linux, but we're actually also on the same team. And we're on the same team because we are completely compatible with each other, and there's no more productized conflict of interest, right? The conflict of interest does not exist between the products anymore, and I'll talk about that here in just a moment. But this really changed kind of the landscape of what I like to call now as being the enterprise Linux standard. And it's a huge benefit in my mind. But what this meant for CIQ was, well, we just founded Rocky Linux. We decided we did not want to put Rocky Linux into CIQ. We wanted this to be separate. We wanted it to be a separate organization because we also, not only did we not want to have to manage a conflict of interest situation with our own products, but we really wanted this project to be seen and to be leveraged by the community for the community. And so we put this project outside of the umbrella of CIQ. We don't want to own this project. We don't want to control this project. We want to contribute to this project, but that's it. If there's any commercial partnerships or support that this project generates and people need help with it, we want to be there to help. That's our business model. We'd like to earn the business behind Rocky Linux, because not only did we found it, but we also have a lot of engineers and a lot of capabilities around the project. So we would like to win that business. And it's not because we own it, and it's not because we're holding it hostage. It's because we believe we can do it best. So that's what we've been doing with Rocky Linux. So we went from being not only a traditional kind of high performance computing organization to then looking at new ways of doing high performance computing and new ways of doing cloud, to now we're also a Linux distribution vendor in a matter of speaking. All right, so now I'm going to take that part of the conversation and now segue into open source. As I mentioned, I've had a lot of experience at this point along my career, really focusing on open source. And I want to say I went from being the Richard Stallman follower, free software foundation type of guy. Everything had to be open source. You have to give everything away if you want to be a good person to the world. I went through all of that, and I realized the amount of difficulties that actually creates with regards to creating a sustainable project. And for a sustainable project to exist, it has to have a mechanism to, well, sustain itself, not only financially, but also from the perspective of developers, organization, and that includes things like, website development, documentation, marketing, branding. All of these sorts of things have to be kind of thought about when you're thinking about making a large open source project. And there's reasons to open source a project. So for example, you get a much larger development base. Well, I should caveat that. You get a large developer base if you're solving an interesting problem to a lot of people. If you're not solving an interesting problem to a lot of people, typically you're going to have a very small developer base. And in some cases, it could just be a developer base of one. I've been there and I've done that. But if you do solve a problem that is fairly pervasive through the community and through other people, you end up not only increasing your usage base, but you end up increasing your developer base. And as a organization or as an individual who wishes to open source a project, this ends up becoming kind of a really, a key facet as to why would somebody open source that, right? Now they have additional development resources coming into it. They also have, in many cases, a larger user base coming into it. So that kind of leads into unrestricted usage. According to the Open Source Initiative, the OSI, to have a truly open source project licensed by an OSI approved license, there needs to be unrestricted usage of that software, no restrictions. So I want to be very blunt when I say this. This means that your competitors could use this software. Your competitors may make more money with this software than the people who founded the software. And if you really want to do open source, you need to be okay with that. You need to realize that you're giving this away to the community, and your success from this open source project commercially has to be because you are the best organization to offer something related to this open source community, not because you're going to hold it hostage. And that has to be a really big reason and a consideration when somebody's open sourcing a project. So, and then the last one is, of course, as you open source a project, you're going to get other people using this project, and that includes other projects. And that starts building the idea of open standards. They may not be formalized standards even, but this is going to create some implied standards. And those standards are going to hopefully, best case scenarios, become somewhat pervasive. As I said earlier, I created a project called Singularity, and even though there's no standards to how Singularity works or what Singularity does, I can say that there's a large number of other open source projects at this point that leverage Singularity directly, both its API, as well as its CLI. So there's a lot of kind of benefit that you get by open sourcing a project. Now, now some warnings. Again, expect your competitors to use this, expect your customers to use this, and if you do have a conflict of interest between an open source project and a commercial project or a revenue stream, be aware that your users using the open source project are going to be seen in some case as a negative by certain people in your company, predominantly sales, that are going to say, well, this is now blocking my ability to go make sales because it's kind of hard to sell something you're giving away for free. So be aware that you have competitors that may end up using this project as well as a conflict of interest that may become apparent. The last thing I really want to mention about open source, excuse me, is that many companies are now looking at open source as a marketing tool that's in their disposal to increase the visibility of a particular project, and they can actually turn that tool on and off kind of at an as needed basis. This is really one of the reasons, or one of what happened with Centos, right? Centos had a large community behind it. It was no longer, seen as a benefit by the company that was really controlling this and sponsoring this, and so it was end of lifed. More recently than Centos is something called Elastic Cloud, or Elasticsearch, excuse me, and they kind of did something very similar. A competitor started making more money than they did, and they wanted to control that. So they end of life the open source, and it actually, according to OSI standards, even though the source code is available, it is no longer considered open source. And if you go back through the last few years, all the way back to, you may recall, another project called MongoDB. And I think that was one of the first ones that actually did this. And since then, between then and Elasticsearch, we probably have about a dozen or so different technologies, especially in cloud, where we've seen this, where we've seen companies kind of switching on and off open source, depending on their own corporate initiatives and corporate goals and needs. And so the one kind of major thing that I'm going to share here is, don't open source something unless you're really ready to stand behind it. If you're ready to make that commitment and you're ready to stand by that commitment and hold to that commitment, then yeah, absolutely. Open sourcing something makes a lot of sense. But if you're looking at it as something that you're looking at it for the wrong reasons, honestly, keep it commercial. I'm no longer an open source zealot. Keep it commercial, right? You don't have to open source things. And as a matter of fact, the ecosystem has shifted a little bit. Some of our primary communication platforms, even for open source software, is not open source. Slack is probably used more than anything at this point, even more than IRC, for open source projects. And it's not open source. So the ecosystem has shifted a little bit. No longer is there the need or the feeling that somebody has to open source something. You can keep it commercial. So that's kind of my big message about open source. And I'd also say it is exactly why that we've done certain things that we have within CIQ. So I'm not just preaching, we're actually doing this. So with CIQ, again, when we developed Rocky, when we founded Rocky and created that, we didn't try to control it. We didn't keep the ownership ourselves. We put it out there into the open source community, created the Rocky Enterprise Software Foundation, which has its tenets in a lot of what I'm describing. And we basically built up the RESF to host this. And the RESF is currently controlled by the community. So we don't want to own it. We don't want to control it. We actually want the community to decide and lay the groundwork for where that project is going to go. And that's how I think people need to be looking at open source. Is there's nothing wrong with hosting it within a company, but just be aware that that's going to be perceived as the company actually holds the rights. And if you're hosting it within a company's GitHub, that makes it even more difficult, which a lot of companies do, because now for external contributors, they actually have to have access to that corporation's GitHub. And you can do some things for a project to have specific collaborators, just for a project to have external collaborators, but generally speaking, it is not an advantageous situation. And many people in the community do not want to be contributing to a project that exists under a commercial umbrella. So again, a lot of things to think about when you're open sourcing something. And from everything that I've seen and the conversations that I've had regarding Cortex, I think Cortex has done a fantastic job here. So none of this is a jab at Cortex at all, as opposed to kudos to Cortex. So let's see, moving on. I'm going to talk a little bit, if there's interest. I have some additional slides that I put in here on what we're doing to modernize high performance computing. And again, I kind of want to bring this up, and I'm sorry, the animations are a little off on this. I kind of wanted to bring this up real quick because, again, I think a lot of the people listening in on this may have an interest in this from the perspective of storage. So when we're thinking about, so I'm kind of going to, and I apologize, the presentation actually, now that I'm thinking about it, kind of went all over the place. I hope everyone bared with me. I'm going to go back to Fuzzball real quick, which is our HPC 2.0 stack. And I'm going to talk a little bit about this for just a bit, because from a storage perspective, I think it's actually really, really interesting. As I mentioned, we are orchestrating workloads as a function of a few things, with storage being a big one of those. And this is a high level view, and I know it's small, but this is a high level view of what a workflow looks like. And the general idea, though, is we're defining what are our inputs for a particular job. What does that job pipeline or job graph look like? And then how are we persisting the results of that job, or where are we persisting the results of that job? And as a result of this workflow becomes completely portable. We can run it anywhere, and it doesn't matter where it goes. That pipeline should always work out, as long as we've considered things like data mobility and access to that data. And assuming all of that is fairly flat, and we can access that data with the appropriate credentials and tokens, this job could run anywhere. That doesn't mean it would run efficiently anywhere, but it can run anywhere. So this gives us the ability, again, to kind of start thinking about things from a much more portable perspective than we've been thinking about it. And okay, got through all the animations. So this is what the stack looks like on a single cluster. I'm not going to go into all the specifics just to save time, but the important piece is that user's workflow, which kind of is indicated at the top left, comes into this stack through something called Fuzzball Orchestrate. Fuzzball Orchestrate will move data, create volumes, deal with container images, set everything up, and then basically run this pipeline or this job DAG across the system. And we manage that on something called Fuzzball Substrate, which can be thousands and thousands of compute nodes or cloud instances. And we manage this whole job and workflow and whatnot. But the important thing here from a data perspective is Fuzzball Orchestrate has certain services to move data. It has the data movers. And these data movers can actually interface and do different types of data movement. So we're already starting to integrate with everybody from to being able to do things like S3 or S3 compatible object stores, to coming off of local file systems, coming off of NFS, coming off of CIFS, as well as other aspects. So we can pull data in from all of these different locations. We're also starting to look at other ways of doing data movement, like grid FTP, and other ways that we can kind of build onto that data movement. So this data movement now is going to go pull data into this cluster, into this resource, and then run this workflow as a result of, or through that data. And again, hold on, let me get through all the animations here. Apologize for that. There we go. So this gets really interesting when we start to cluster clusters together. And we do this with something called fuzzball federate. And you can see on the bottom, we've got multiple clusters. They may exist in the cloud, they may exist on-prem, they may exist multi-prem, they may exist multi-cloud. And what Federate does is it exposes the exact same APIs to the user. So the user is now submitting their same workflow into Fuzzball Federate as they would into a single cluster. When that cluster gets, when Federate gets that workflow, instead of immediately starting to do data movement and whatnot, instead, Federate thinks about the job from a very different perspective when it comes to policy. It thinks about it from the perspective of what site, what cloud, or what cluster should be running this particular workflow based on architecture availability, resource availability, as well as data locality, data mobility, data gravity, and data security. And then once we identify where we want to run a particular workflow, you can see this data lake kind of sitting above this. This data lake, for this to work properly and effectively, has to be reachable, but also secured. And it has to be reachable to all of these different locations. And we want to be able to reach this with, as fast as we possibly can. We want to be able to reach this with as low latency as we possibly can. And we want to be able to do this without having to deal with ingress and egress costs if we can. And that's one of the reasons why we have a fantastic relationship with Seagate, to be blunt. So we are thinking through this from that perspective. And this data lake needs to exist in a cloud agnostic and cloud neutral way. And we can move all of these jobs and all of these resources around in such a way that is highly efficient. And we can do things like follow breadcrumb trails on, have we already scheduled this data to run somewhere? And if so, is that data still being cached and maintained at that location? And so we can really start thinking about all of these sorts of things from the federate level. And this is something that we haven't really been able to consider before because we haven't had this ability to go completely hybrid federated meta orchestration before. We just haven't been able to do that before. So that's the kind of stuff that we've been thinking through and that we've been building. And at this point, we are in proof of concepts with this, with a number of different sites. We are already thinking about how to move some of these sites. That's a funny way of saying it. The sites is plural. I guess sites is already plural. How to move the site's data to a agnostic location where they can run it, whether it be on-prem, multi-prem, cloud, multi-cloud. And then the last stage of this, of course, which I haven't mentioned yet, but you might actually already see this, is with this architecture, it's also very easy to go out to the edge and far edge. So we can actually manage workflows going all the way out to that far edge. So that's what we've been building. And I've been talking and yammering for a while, so I'm going to go ahead and stop and see if there's any questions.
Well, people can drop questions in the chat, or I will see about changing it so people can unmute themselves. If anybody wants to jump in.
Yeah, and Rachel, while you're doing that, I'll go. Greg, thanks for this. It's a great talk. Really appreciate this. I got two questions. Is it possible that what happened to MongoDB that you mentioned earlier and Elasticsearch could happen to Rocky Linux? And then number two, why is Rocky open but Fuzzball is not?
Okay, two great questions. The first one, is it possible it can happen? Not in its current state. Now, it's important to recognize that, there's always matters that you have to contend with. So for example, CentOS was I'm still pre-coffee. My tongue is not going fast enough. CentOS is actually came out of the Chaos Foundation, which was a 501c3. So it was a nonprofit organization. So you can see how Centos was kind of taken out of that nonprofit organization. It was actually taken over by an individual. This is so sometimes when you have people that are less than excellent getting associated with open source projects, sometimes you end up with outcomes that are less than excellent. This person took it out of the Chaos Foundation, took it on themselves. The person went kind of AWOL. You can review this in something called the Centos Debacle. There was a open letter from the Centos community to this person. I don't wish to name the person, but the Centos community and developers were basically asking for control of the project, considering this person went AWOL and was taking all of the donations for himself personally to the project. So they had to basically get a hold of that project again. So then the developers owned the project. They got control of the project, and then after about 10 years, they had a little bit of burnout, I would assume, going on. And please keep in mind, the Centos team, they were very small. It was only about 5 plus or minus 2 or 3 at any given point. So it was a small team, and they did it for, the entire life of the project. But about 10 years into it, Red Hat offered them some jobs, and they all went over to Red Hat, and they took Centos with them and then handed Red Hat the keys to Centos. I'm assuming that they had a really great employment contract, but I'm not privy to that information. I hope they do. Let me leave it at that. And that's how Red Hat basically got a hold of the project. So I've learned a lot of things along the way. For example, how to protect the project, how to make sure that not any single individual can basically take over the project in a negative way and run away with it. And it ends up basically building the answer ends up being you build an organization that has a series of checks and balances such that even though I'm the founder of it, I can't do it. I don't have access to all of the infrastructure keys, for example, even though I have access to the organization that runs this and controls kind of the brand. I don't have access to the infrastructure. And that's held by a different group of people. And then there's another group of people that basically kind of run different aspects of it, like the GitHub, not GitHub, sorry, the GitLab. And so by having these kind of separation of duties and building the infrastructure in such a way that there's always going to be a much larger community around this than just 5 individuals, we've created in what we believe is a situation in which we're not going to be able to, that just can't happen. It can't happen because too many people are controlling different aspects of the project, and that's by design. So that's my feeling on the first one, and I believe that that Rocky is definitely going to persist longer than Centos did. But even if it persists for just as long as Centos, that's 15 years. That's a pretty good amount of time. But I actually have no doubt in my mind that it's going to persist considerably longer than that. So that's your first question. The second question had to do with why open source Rocky, but not Fuzzball? And that's a really good question. And the answer really comes down to I'm not ready to make the commitments that I was talking about earlier, specifically competitors. I'm not ready to give my competitors the heads up and the ability to go monetize on this platform yet. It's funny. I was having an interview with somebody from Forbes, and a technical, interviewer from Forbes. And at the end of the interview, and I'm not joking, this person said to me, and it was confidential, so I'm not going to say the person's name. I mean, they don't want it out there, but they basically said, "Greg, this is huge. This is such a big deal. This is a game changer. I know your whole background is open source. If you open source this, I personally am going to fly over there and I'm going to take this pen and I'm going to stab you with it." And the reason for that is such. Competitors and other people would be able to monetize on this and take over this. And given the fact that we're a small company, this is our primary or one of our primary strategic kind of initiatives. I'm not ready to give that up. I'm not ready to abide by my own kind of guidelines on why should you open source a project and how do you manage that. And because of that, I'm not going to do it in pardon my language here, but in a half-assed way. If I open source something, it's going to be 100%. It's going to be for the community, and I'm not going to try to, keep my reins on it and try to control it. No, I want it to be completely open source. I want it to be completely free. I'm not ready to make that decision with Fuzzball. And so as a result, it's commercial. I'm not even going to pretend it's open source. It's not. At some time in the future, we've already had some conversations with some large government entities, some large federal entities that have basically said, at some point, we would love for you to open source this. And at some point, I'll be absolutely open to it. And they're even willing to help fund some of that and to say, we realize you may be taking a risk in doing that, but being open source is so important to us that we'd actually be open to, in a couple of years, once, there's a number of sites leveraging this, we do want to see this open source, and we would be willing to pay for that. And so that's kind of where we're at right now. And I'm not suggesting that that I'm waiting for a big check in order to open source this, but I am suggesting that I myself am not ready for the commitment of open source with regards to Fuzzball. We have got to first make a sustainable business before I can give this away for free, and then give this away to the community. But please note, and you can feel free to mark my words on this, when that time comes, I would very much look forward to open sourcing this.
Thank you. I see we have a question on a different topic from Pete. We have, in Fuzzball Federate, is there a centralized mechanism for managing metadata from the various sources?
So there's a number of things, and I'm going to be blunt on this. I'm an engineer at heart, so the idea of selling something that is vaporware it just rubs me the wrong way. So let me be very clear. I see what we've built up as a huge, massive initiative, and we are a small startup. So what we've done is we've approached this from the perspective of building the foundation and building the structure, the base framework for how this is all going to come together. We have left a number of pieces that still need to be developed. And we're actually in our next funding raise, excuse me, to go and increase the engineering team and increase the development team to go build a lot of these pieces that are still not completely fleshed out. How we're doing the data breadcrumbs, how we're doing the metadata management through Fuzzball Federate is, at this point, we have hooks, we have things stubbed out, but we do not have a huge amount of logic in that section of Federate at this point. We are anticipating that by end of this year, going into Q1 of next year, we should have that fleshed out. And it's going to be an evolution. And just like the data movers, that's going to be pluggable. So we are hoping to work with vendors as well as other projects that are solving this problem and doing it potentially much better than we would. And we would like to integrate with them and bring those capabilities to market through Federate. So to be clear, and just to reiterate, we do not have all of those pieces built yet. We have them sketched out, we have them stubbed out, but yeah, we do need to make more headway on that. We have some ideas on models on how to do that. And how I use the term breadcrumb is kind of how we are thinking about it. At least how I'm thinking about it. The engineering team and CTO may like to go into it from a different perspective, but I like to think of it as breadcrumbs, right? So when a job comes in, it's fairly easy to figure out, without any insights, what is the distance to that data? What is the bandwidth? And you can do that by obviously pulling a very small bit of that data and just benchmarking that. You can do that by figuring out, and applying some policy mechanisms to, if that's up in, let's say, S3, what is the cost associated with moving that data? How big is that data? And you can start to make projections. You can also make projections on how much would it cost to run this job in EC2, so you don't have to pay for egress. So you can start making kind of informed decisions about this. But again, a lot of that decision-making portions of the policy are things that we have fleshed out to basically finish in Q4 of this year, and hopefully have this to market again right before the end of the year and going into Q1.
Let's see, we have raised hand, but not a question. I don't know if that was an accidental click. Pratik, if you'd like to unmute, you can ask a question. There you go.
Perfect. Just a question which came to our mind. In a multi-cloud environment, what does Rocky do, or rather have plans to support like data sitting in multiple clouds for maybe, let's say, aggressive architectures like Lambda-based computing? What are the different, what is your view of the problem? How do you ensure that it is in a sandbox environment, and how does the metadata like protection look like? What are your views on, like, my main question would be, what are your views on the aggressive architectures which are coming up, and how do you support it? Because currently AWS has a problem with the, and that's why they set a limitation to it. What are your views in it, if I may ask?
Yeah, so great question. So you mentioned Rocky at the beginning of the question. So real quick, I'm just going to reiterate from a Rocky perspective, there's not a huge amount that we're going to be focusing on there as being basically the fundamental core operating system part. There's really not the orchestration or data movement pieces of that operating system that would really apply. But for Fuzzball, and specifically Fuzzball Federate, your question is absolutely in aligned. So for Fuzzball and Fuzzball Federate, we're looking at how to manage the, let me get my thoughts in order. I'm not sure I'm actually going to be able to answer this question wholesale, only because we're solving a little bit of a different problem than Lambda. We're focusing on the compute side, and I may not have made this very clear earlier, and I apologize for that. We're looking at this from a kind of new version of high performance computing, rather than things like functions and whatnot as a service. So we're looking at this from it for existing HPC type workflows. And let me be really clear when I say HPC. HPC is kind of it's a very old school way of describing how we do parallelization of processes across, systems, and how do we pull all of this together. Now, with that, sorry, I just heard something and just want to make sure everything's okay. Yeah, it is. So from that perspective, we're looking at this from a data perspective, very similarly how we would to HPC. Now, one other facet that I'll mention real quick is enterprise HPC or HPC-like workflows from things like AI and ML and compute and data-driven analytics. Applications that we're seeing enterprises utilizing now are fairly similar to high performance computing, right? The nature of those applications is very similar. So when we're looking at high performance computing, I'm not just thinking of simulation and what you'd see at a government lab or at a pharmaceutical or an aerospace model or something along those lines.
So my main question was that when you have aggressive architectures like Lambda computing, how does and that has a short runtime, right? And so bringing up the DAG and doing all the computation may take more time than actually deploying but that causes some security flaws. And I wanted to know if you are aware of such developments in Rocky, and because AWS suffers a lot because of that.
Got it. So there'd be nothing specific in Rocky, but what you're describing for with regards to now I get your question regarding Lambda. So you're exactly right. Lambda would basically have a number of very kind of fast running jobs. And in high performance computing, we call this high throughput computing. And it's a little bit different than Lambda, of course, but if we were to use kind of the same sort of problem that we're trying to solve with high throughput computing, what we would want to do there is inside of the workflow, you'd have one workflow, but that one workflow basically references either a job array, or it could do a diamond shaped DAG or a Y shaped DAG where it's lots of forks in that DAG. The DAG optimization is actually going through a workflow engine. Let me actually back up a slide here. I have to go through all the animations, which I didn't use right there. We're actually going through a workflow engine here that is actually incredibly optimized. And so it can actually dispatch out jobs very, very, very quickly, but you're 100% right. There's an overhead with every job that needs to be brought up and the teardown of every job, specifically because we're leveraging things like, as I said before, containers for every piece of the job. So there is a latency there. Now, you mentioned a security aspect, and I'm not sure exactly what the security implication would be unless you're foregoing certain security, validation checks and whatnot in order to optimize the performance. We don't do that. We have one proof of concept right now going with a organization that's looking at data security extraordinarily heavily, and they're trying to figure out how to assign credentials to data, or rather, I should say, permissions or ACLs to data that states not only who is allowed to access that data, but what application sets or containers based on key signing fingerprints of those containers is allowed to access that data, and what systems are allowed to host that data. And we're thinking of it from that perspective as well. And once we've identified that, the high throughput aspect of this within a given workflow, I don't anticipate is going to have a huge effect in terms of throughput. But there is always going to be the tear down and the bring up costs and the penalty of doing that through a container. It's not massively huge. We're probably about, I'd say, last time I looked, it was about 1 to 200 thousandths of a second. So I think we're going to be fine on that. From that perspective, and we are still sandboxing everything. So from that perspective of the security of the data, everything is basically being stored and cached into basically SE Linux, covered sandboxes. And everything in that sandbox is basically, it could be ephemeral, so we're blowing it away after it is completely done. And in some cases, we're actually rebooting systems to get rid of any memory resident pieces of that data. So it really all depends up to the use case in terms of what those needs are. I'm rambling a little bit, hoping that I'm just kind of using very thick broad strokes, hoping that I'm hitting a few answers. But yeah, I'll stop there.
Thank you so much, Greg. It actually answered some of my questions, but I think I need to go through more or fuzzball so that I can understand it better. Thank you so much.
I'd be happy to actually put you also in touch with people who on my team who know this much better than I do. I know the high level view of this. I know kind of the architecture of how stuff works, but more specific stuff, I tend to rely on my CTO and engineering team for, because they're the ones actually building it.
Thank you, Greg.
Absolutely. So feel free to reach out to me.
Sure.
Okay, well, unfortunately, I normally ask if anybody had any other questions, but I see that we're over time. So I just wanted to really thank everybody for joining us and for Greg coming to speak. Do you want to have I want to make sure I give space for the last word to go to you, Greg.
Thank you so much. I don't, it reminds me of, in an argument, the person who always wants the last word. I don't want the last word. But with that said, it's just a thank you very much for inviting me, giving me the chance to talk and share what we've been working on and some of my perspectives and opinions on open source and whatnot. And I hope the talk was interesting to people. And if anybody has any questions, please do feel free to reach out to me. You can reach out directly, or you can reach out through Rachel.
Awesome. Thank you so much. Let me just put our closing slide up here. And I hope that everybody will join us again next month. So stay tuned, pay attention to the newsletter. You'll find out who we're going to have speaking. And thank you.